Okay, recurring decimals. Express this says here 0.004 with a dot on it as a fraction. So basically what you do is you just let x equals this, and where the dot is, that just shows it's repeating. So you've got 0, 0, they're not repeating. It starts repeating with a 4. But because there's a single dot, it's the 4 that just keeps repeating. It goes on and on and on and so on, right? Dot, dot, dot. What I'm going to do now is, I'm going to times it by 10. So 10x. If I times it by 10, every number shifts at one place. So it ends up like that. The 4 there would move up one place, and then all the other 4s would just follow suit, would move up. So you get an infinite amount of 4s, so we keep going like that. Now we've got to keep going, because if you check after the point, they look different, don't they? You know, this bit here is different, so we've got to times it by 10 again. So times 10x by 10, we get 100x. Okay, if we times 10x by 10, you get 100x. Times this by 10 shifts it up 1 again. Okay, so the 4 goes up 1 and all the 4s follow suit. Okay, etc, etc. Now again, check after the point, and there's nothing the same here, they're different. So times it by 10 again, 100 times 10 is 1000x. Times this by 10 and it shifts up one place, so you get 4.4. Okay, so the 4 goes up one place, so it goes there, and then all the other 4s follow suit, they all move up one place. It's an infinite amount of them, so it just keeps on going. Now check after the point. Can you see these two after the point? They're identical after the decimal point. So when you found that some that are identical, what you do then is you take them away. So you do 1000x take away 100x. So 1000 take away 100 is 900x. And then what's interesting on this side, 4 take away 0 is just 4. And then all the decimal places here, take away these decimal places, just 0. So you end up with this. So x then will be 4 over 900. And you can leave your answer like that, right? There's no need to simplify this job done. Only simplify if they ask you to. Right, so it says then number 2, express this as a fraction. So again, I'm going to let x equals. Now in this case, I've got the 0.34, that's there, nothing repeating there, but it's the 2 and 7. As you can see, there's dots above 2 and 7. So it starts repeating at 2, ends repeating at 7, and it keeps going 2, 7, 2, 7, 2, 7, etc. So again, I'm going to times it by 10. So 3.4, right? So shifts up one place. So the 3 goes one place over. 2, 7, 2, 7, 2, 7, 2, 7, 2, 7, etc, etc. Times it by 100, so moves up another place. So 34.2727272727. Now again, after the points, there's nothing the same. So I'm going to have to times it by another 10. So that's 1000. Make it 10 times bigger. Move this up now one place. 342.72727272, etc, etc. Now again, check after the point, and there's actually nothing the same again, so I'm going to have to go again. I'm going to have to times it by this by another 10, so go from 1000 to 10,000. So 342727272727, etc, etc. Now if we compare, you could see now this one and this one are the same. Okay, after the point, they're the same. So if I take away 10,000, take away 100. Okay, so compare these two. 10,000 take away 100 is 9,900 x, and then 3427 take away 34. So if you do the maths on that, you get 3393. Okay, if you take that away carefully. And then after the point, they all go, don't they? Two 7s, they all go. So you end up with that, and then x will equal 3393 over 9900. Okay, job done. Question 3 then, it says express the following as a recurring decimal. Now, to express this as a recurring decimal, we just need to divide. Okay, so you do this, 1 divided by 9. Okay, use the bus stop method. 1 divided by 9. Now 9 doesn't go into 1, so put a 0 here. And I need to carry that 0 over, but there's nothing there, so I need to put a point and a 0 and a few zeros probably to make it obvious. So 9 doesn't go into 1, put a 0, decimal point up there as well, carry that 1. 9 into 10 goes once, with remainder 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 1, etc, etc, etc. You can see we're going like that. The answer will be 0.1 with a dot on it to show it's recurring. 2/15. Okay, so in this case now we need to divide 15 into 2. Okay, 15 doesn't go into 2 obviously, so put a 0 there. Decimal point, zeros, loads of them. Okay, so carry that 2. 15 into 20 then goes once with 5 remainder. 15 into 45 goes 3 times, doesn't it? That gives you 45, so there's 5 remainder. 15 into 50 goes 3 times, 45 with 5 remainder. 15 into 50 goes 3 times, you guessed it, with 5 remainder. 15 into 50 goes 3 times with 5 remainder, and so on, right? So we get this here. So the answer then would be 0.1 is the 3 that's repeating. So you put the dot above the 3. This one then, 3/7. Okay, so you're going to divide 7 into 3. Okay, so put loads of zeros here. 7 doesn't go into 3, so you carry it. 7 into 30 goes 4 times. Okay, 7 times 4 is 28, so 2 remainder. 7 then into 20 goes twice, and that's 14, so 6 remainder. 7 into 60 goes 8 times, and that's 56, there's 4 remainder. 7 into 40 goes 5 times, and that's 35, so it's 5 remainder. 7 into 50 goes 7 times. 7 times 7 is 49, so there's 1 remainder. 7 into 10 goes once, okay, with 3 remainder. 7 into 30 goes 4 times with 2 remainder, because 7 times 4 is 28. 7 into 20 goes twice with 6 remainder. Okay, so let's stop for a minute. Let's see if we found the pattern, because it didn't look like it, but if we look closely now, 4, 2, 8, 5, 7, 1. 4, 2, if I kept going, 8, 5, 7, 1. So this one, although it's quite obscure, there's your repeating pattern. So you put a dot above the 4, dot above the 1, that's the recurring sequence there. Okay, so it's 4, 2, 8, 5, 7, 1, 4, 2, 8, 5, 7, 1. Okay, so question 4 then, it says evaluate this here, 2/9 plus 0.02 recurring. Now you need to work out what 2/9 is first of all. Okay, so 9 into 2. Now of course 9 doesn't go into 2, so that's 0. Carry the 2. 9 into 20 goes twice, and that makes 18, so remainder 2. 9 into 20 goes twice, and that's 18, remainder 2, etc, etc, right? So 2/9 is 0.2222222, and so on. 0.02 recurring is 0.02222, and so on. So if we were to add these, because that's what it says there, add them, adding them, you get 0.2444444, right? If I line them up and add them properly, that's what you get there. Okay, and then what you do then, you go through that same process we did at the start. Put this as a fraction, so you let x equal 0.24444, etc, etc. Then do 10x, which would be 2.444444, and so on. Then do 100x, 24.444, and you notice then that these two are the same up to the point. So we take away these two. 100x take away 10x is 90x. 24 take away 2 is 22. 4's go. X then will be 22 over 90.